Welcome to our YouTube channel. Today we are going to be talking about superposition theorem. So this superposition theorem is part of circuit theorems. It's one of the theorems that we can use to solve the currents that are passing through a circuit diagram. So if you want to determine the currents that are flowing through elements in a circuit diagram, we can use superposition theorem to do that. Right? Now, what do you mean by superposition theorem? The idea is that this theorem, we can only apply this theorem when we are dealing with linear system, right? So it's very important that we understand what a linear system is. A linear system is a system that obeys the principle of superposition. And the principle of superposition has two main properties. One is homogeneity property, and the other one is additivity property. Additivity property or homogeneity property are required before we can say that a system is a linear system. So a system has to satisfy both of these properties. Now, when it comes to homogeneity property, what it means is that if you have an input into a system, so you can consider a resistor to be a system, right? So if you have a resistor and the current passing through is the input and the voltage is the output. So if we were to multiply the current by a constant K, then our output, which is the voltage across the resistor, has to also be multiplied by the same constant K. So that's homogeneity. And then when it comes to additivity property, again, we are dealing with the resistor as about system. That means if you have sum, as the name implies additivity, so we are talking about addition, right? Or the sum of current into our system, which is a resistor, is equals to what? Also, the output here, we have the sum of what? Output, right? So we have this, our resistor that we have in this, the circuit diagram that we normally have, all the resistors that you can find there, they are all what? Linear system, right? Because they all obey the principle of superposition. Now, after knowing all these properties and homogeneity and then additivity property, now we can go ahead and then focus more on the theorem, right? Superposition simply says that the current or voltage across an element in a circuit diagram is the algebraic sum of the current or the voltage across that element due to each independent source acting alone, right? So what that means is that if you have a circuit diagram and you have, for example, a resistor in the circuit diagram, and you are interested in trying to find the current passing through the resistor in the circuit diagram, for example, as you can see here, this is an example. We have resistors, we have 3 resistors in the circuit diagram and then 2 voltage sources. So if we are interested in finding the current passing through our one, what that means is that we can find the current by making sure that one of these voltages is active, all right, meaning it's acting alone at a time. Then we find the current passing through R1 due to one of them being active. So for example, I can make V1 to be active and then turn off V2. And how do we turn this? Is V2 is a voltage source. So how do we turn off a voltage source? We turn off a voltage source by connecting a wire, right? When you connect a wire and then the wire, as a result of the wire, the voltage source will be short circuited, right? So when you come to turn off a voltage source, you short circuit the voltage by connecting a wire. Now, so once V1 is active, we can get the current passing through I1 due to V1 acting alone. So we get that current. And once you have such a circuit diagram, you can now use any method to find the current passing through what R1. So you can use network reduction method, nodal analysis, right? Or you can use branch current method, or even mesh analysis method to solve for the current passing through R1. And I've made videos on all these methods, right? So you can go and watch them if you are interested in how you can use them, any of those methods to solve for the current passing through R1 due to what V1 acting alone. Then, now that I've gotten the currents passing through what R1 due to what our phase voltage acting alone, then I'll go to and then I'll now turn off the phase voltage, which is V1, and then make sure that V2 is what active, right? Then we get the current passing through R1, right? So here's to be R1 due to V2 being active, right? Now, after getting the current passing through R1 due to V2 being active, then you do the algebraic sum. The algebraic sum of the current will give you the actual current passing through what R1. And you can see here, and doing the algebraic sum, it's very important that you pay attention to the direction of the currents. So the first diagram, you can see the current is passing through this direction, right? And then when you come to the second current here, it's opposite that of I1. So that means we can take this direction to be positive. So if the other current is opposite, then that becomes negative. So the algebraic sign here will be I1 due to what V1 acting alone minus I1 due to V2 acting alone. That will give us the current passing through the resistor R1. So this is how you apply superposition theorem. You can, if you want to know more about this, I will probably answer. I'm probably going to give another example, right? And then please make sure that if you find this video interesting, you can like and share, and then make sure that you subscribe to the channel. Hello, we are going to look at another example, right? So this time you can see that we have a voltage source and a current source. And at the same time too, we are interested in trying to find the current passing through R2. The first one, it was current passing through R1, and we have two voltage sources. This time we have a voltage source and a current source, and we are interested in determining the current passing through R2. All right. Now, how do we get the current? The current passing through R2 is going to be equal to the algebraic sum of the current passing through R2 due to each of the independent sources acting alone. So here we start with the fact that the voltage source is acting alone, and we turn off what? The current source. When it comes to turning off a current source, we remove the current source. Turning off a source simply means that we are trying to make sure that at the location of what? The source, the value there becomes 0. So if it's a current source, we want to make sure that the current passing through that location of the current source is 0. If it's a voltage source, we make sure that the current passing there is 0, right? I mean, the voltage there becomes 0. So when it comes to a current source, we want to make sure that current becomes 0. So we remove the current source. As you can see here, we remove it, and now you have an open circuit here. Now that we've done this, we are now going to find the current passing through R2 due to the voltage source Vs being active, right? Acting alone. So what that means, now we just get a simple circuit, right? You solve for the current passing through this using any of the methods, right? You can use here a branch current method or nodal analysis, or just simple network reduction for, and you get what? The current passing through. I2 will do to what? The voltage source acting alone. Now we come to the next circuit diagram. This time we are going to turn off the voltage source by connecting a wire, meaning we short circuit the voltage. That will make sure the voltage there becomes 0. Then this time we have our current source. Now, looking at the current source here, the current source here becomes the current passing through what? R3, and then it arrives here, and we have a node, right? And then we have current passing through what? R2, right? Which is our interest, right? We're interested in that current. Now, when it comes to finding this current passing through R2 due to what? This current source acting alone, that simply means here, this becomes the total current. The current source here becomes the total current. Then you can now use current divider rule to find the current passing through what? R2, right? After this, we perform algebraic sum. And the algebraic sum here is just going to what? Be the sum of the current passing through what? R2 due to the voltage source acting alone plus the current passing through what? R2 due to the current source acting alone. And here to be addition because the currents here, they are all in the same direction. So just do addition. Now, thank you for taking your time to watch this video. If it's your first time of what's coming to watching a video in this channel, make sure you subscribe and then share the video with your colleagues and friends. Bye-bye.